So thank you very much for staying with us. 4:30. You're truly a strong and powerful people for staying for this long. And Jeremy told me also that there would be beers after this talk, and we're also raffling tickets to the OpenStack, to the next OpenStack session. So thank you for joining. I hope you stayed for the session. And if not, then at least you might get a chance to win a ticket. So today's talk is going to be about cloud-native VNFs, obviously an view-oriented talk. And who here is in the telecom industry in the crowd? Who is not in the telecom industry? Kind of, okay. So the second question would be, who here is from the service provider side? Raise of hands. One, and from the vendor side? Awesome. So I'm hoping you will find this talk a little bit interesting. This is a little bit more focused towards on how to build an NFV, like approaches, how to build the VNFs and approaches, etc. So just feel free to ask questions, etc. So I'm Arthur Berezin. I'm an OpenStacker since the SX release. Build OpenStack environments. Worked with several companies around OpenStack. Building an OpenStack production environment, specifically with Red Hat, LivePerson, Matrix, and others. So quite a skin in the OpenStack industry. And now I'm the director of product management for Cloudify. Obviously working on Cloudify, but also a few interesting projects around NFV orchestration. So we started a project called Aria Tosca, which is a Tosca-based engine for orchestration. I served as a TSC member in OpenO, and now active member in the ONAP community that is just forming. Just a quick intro on Cloudify, just so you would have the perspective of what we're doing. Obviously, we had a lot of interesting discussions here throughout the day on what Cloudify is doing. So Cloudify is a cloud orchestration platform for obviously an offering for the NFV space, where Cloudify serves as a VNF manager and also as a service and resource orchestrator. And you can see it, where it fits in the Etsy NFV architecture. Doing the full lifecycle management of VNFs. Essentially, we took all the lessons learned and the experience we gained in the web scale front, and then essentially applied that to the NFV space. Today's talk is not not a product pitch or something, and this is probably the last part when I'm going to touch about Cloudify. Rather, I'm going to focus specifically on NFV and the transformation that is right now happening on NFV. I think we're right now starting to see the first implementation from the various VNF vendors. Starting approach at the NFV 2.0 era, where we are a little bit more cloud native. We're still far along from that, but at least we are hearing a lot of the thinking about how to build a cloud-native VNF from the various VNF vendors. So that's a they're very exciting times for us for starting to build these more cloud-native network applications that can, in fact, leverage all the goodies that we can get from all the pieces of the stack that we've just heard today and that we are using in our environments. So, we all know that the traditional world where we had, service providers essentially, picking up the phone to their favorite vendor and saying, hey, please give me blah, blah, blah service. I would like to pay you this huge amount of money for that. And, obviously not all were happy with the situation, and it obviously was very slow, vendor-driven. Vendor dictated the terms, dictated the features that they would provide. And the onboarding of such a service was very, very long. Obviously, 18 months is just an example, but I've heard, by far worse scenarios. And obviously, once I have onboarded this service, the service is very static, right? So I've already started serving my customers. It's a production environment. I, in fact, almost don't touch it as a running system. And, obviously, such a system is very costly. So we're all, very excited that Etsy sort of put the rubber stamp on virtualizing network services, and in fact define not only that it's perfectly fine to run network services as virtual machines, but also took it to the next level and in fact introduced a reference architecture and introduced a set of standards on how to virtualize network services. And this is sort of the first disruption that we've seen in the market. We all now experiencing on what's happening in NFV, where we take applications and run them as virtual applications on top of whatever virtual infrastructure management platform, OpenStack, or in some cases VMware as well. We're also seeing these applications run on various clouds. So that's the first step of evolution, where we took these monolithic applications, very custom appliances, machines, and in fact virtualized them and used commodity hardware and commodity software, or at least some pieces of commodity software, to run these applications. Where one of the key elements that we see here is that the application itself doesn't see too many changes, right? Where this is in this first step, we just took the existing applications and virtualize them and maybe add a thin management layer that would be able to just install these applications on top of whatever virtual infrastructure management that we are using. Most commonly, it's obviously OpenStack being chosen for this, but it's about installing that application and in fact providing it as a virtual appliance. So obviously we've solved many of the challenges, or we solved some portion of the challenges we had for installing such environments, and now the 18 months turned into hours or days or maybe weeks to onboard a new application. We're going through the certification, testing, etc. But now, since everything is software-based and software-defined, it's a little bit easier to do the tests, to do the onboarding, to verify the application, and so on. But we are still, hearing obviously some major faults in having everything just virtualized, and we're hearing this from the top operators in the world. We have guys like AT&T, Vodafone, Tele2 saying, Deutsche Telekom, for example. This is just just one snapshot of a light reading article. Obviously, there are many more evidences to that. To those guys saying, hey, we are running these applications on multiple virtual machines. We have one single application per virtual machine. We have tons of virtual machines, meaning we have tons of operating systems virtualized, duplicated across our environment, and we don't need that. We want the application. We don't care about the extra layers we are onboarding in our environment. So that in fact leads us to the next disruption we are going to see in this telecom space, onboarding these applications into a new, more modern environment, which is the cloud native environment. So what that means is that the applications and the network services, network functions that we are going to use, or the service providers would like to use, they would like them to be aware of what's happening in the layers underneath the application, and to consume and make best use of these applications, right? So the first step is obviously to be able to be aware of the APIs and the options that these layers actually provide, not just live in my small box in my nice cozy VM, rather to understand that I'm running on for example, on a Docker container, understand that I have a pod, and in my pod I have another companion running next to me, very close to me, so the calls to that next container, the container that runs next to me, are much cheaper than making calls to a container that runs on a different pod, for example, right? Or to make a call that runs on a different region, maybe. It's much more expensive to do that call than just something that is much closer to me. So obviously, a few characteristics of such an environment is obviously full automatic, which we've kind of solving these days with obviously Cloudify is one solution for that, but ONUP, we're also seeing that portion being commoditized. Obviously much better hardware efficiency in such environments. We don't run all these extra OSs and extra layers of software that we don't really need for the application's needs. So obviously these are much more efficient right now and commodity costs, since this is an application that I just onboard into my cloud. So again, all these extra pieces are now using commodity pieces. Obviously open source is a major contributor in this space. So now think of such an application that has been written, think of a router or a firewall or an IP detection mechanism. So now think of a software vendor that creates that service or that solution, their software, and uses mechanisms to understand on what infrastructure it runs. Think of that software would have access to Open Daylight, for example. It would be able to understand the Open Daylight's APIs. It would be able to understand OpenStack's APIs or Kubernetes APIs maybe. It would be able to understand, whether do I have optimizations for hardware, right? Or for example, do I have the PDK or FDIO? Do I actually have them as part of different pieces of my application? Now, if I'm writing my application and I'm aware of what's happening there, so now think of the scale my application can reach, right? Think of Google scale for such scenarios. Obviously, when I'm consuming and leveraging these capabilities, my application is obviously architected to expect failures. For example, I do know the fact that I'm running next to another companion in my pod. If a failure happens to a node, I can fail over to a different node, for example, or I can do a failover inside that pod, and architect my application, using all these mechanisms. Operations-driven onboarding, so all the onboarding process is obviously fully automated and fully optimized to the environment that I'm running on. It's not just some custom set of configurations that I'm doing, rather the application itself leverages that. Underlay and overlay. So right now what we're doing is that we're having multiple layers of networks, and we're doing a lot of encapsulations, right? Think of an application, think of, for example, of a virtual router that does for example, VLAN, for example, and that is done in the overlay layer of the networking inside the VM itself, right? This is what we actually are doing today. Now, underneath it, in the actual physical layer, we have physical switches, and we're doing all of that, encapsulation way too many times. So our, the data that we transfer, to transfer 1 bit of data, we're having tons of extra information that we are passing along that in fact we can just, we don't actually need all of that. Now think of an application that is actually aware of the architecture that it uses underneath it, so we can, it can leverage all these components. And one last element, obviously, pricing, right? Have we talked about what it means to buy a cloud-native application? Like, how do I calculate pricing for that? How do I calculate size on that if the application can scale up and scale down based on the load that it experiences, right? Because these days we are sort of used to buying appliances. Are we buying now VMs, or are we buying VNFs based on number of VMs or number of cores? In a cloud-native era, would we buy containers, or would we buy bare throughput? I don't know. So that's another question that we probably should start discussing right now, and reach some sort of a commoditized solution, so all the market in the NAV space, in the telecom space, would be able to to be at least a little bit better aligned, and not scattered across multiple types of business models around that. So a few examples of companies that are taking that step and starting their journey toward cloud-native VNFs. Obviously, each of the examples I'm going to give are still have a lot of path ahead of them. But Versa is one example. Versa has a cloud-native, almost cloud-native VNF solution. They have an SD-WAN set, a set of solutions, and VCP solutions that are, the distribution, orchestration, and management and deployment of their VCPs, for example, is fully automated. So it's very easy for me right now to do the deployment and onboarding of these VCPs across multiple sites. And there are many, many integrations that are already done to do very interesting things and optimized way of deploying many of their components. So this is an example for the self-managed environment where I have a central manager for that environment. Also, another interesting use case is Ruckus. So Ruckus is a wireless provider. They're selling, in fact, Wi-Fi hotspots, and the way to do that is that they have all the management for their Wi-Fi connections being done in a SaaS model. So all their Wi-Fis are connected to an online management piece, and they're doing all their management of that layer using as a software as a service model. So that's also another very interesting example of an application that takes some leverage of the knowledge that it has over the architecture of the network that they are consuming to reach and to do their functions that they were designed for. So what it means, what a blueprint for a cloud-native VNF looks like, in fact, what does it mean to run a cloud-native VNF? So, most of us, or many of those who I speak to, think of cloud-native VNFs as being, just, hey, let's containers everything, we're cloud-native, right? So there are many elements to that. I've just, highlighted a few points that I think are fundamental and a key to starting that road to being cloud-native. So the first is software-defined, right? We want all the pieces of our application, all the layers, all the components to be software-defined, to be fully automated, to be able to provision them using software, reconfigure them using software. Obviously, every manual step or every step that we cannot automate would be very challenging. Again, it would be challenging to scale, right? If there's a person that has to do some sort of operation manually, hey, that's a point where scale that specific operation would be very challenging. So designed for DevOps, obviously, mantra of many DevOps guys is to be able to automate everything and to do all the configuration as code. So take the best practices that we've learned, we as an industry learned in the DevOps space, where we optimize many of the processes, right? DevOps is not the use case, or the need is not new. Rather, we found a little bit better and more optimized way of doing that. And in fact, a byproduct of that was to automate all the processes that we are doing as part of our development. So take the best practices that we've learned, CI/CD, for example, for delivering specific upgrades, patches, etc. for the application. Take all the best practices that we've learned as an industry and apply them to network services, right? For example, I am a service provider. I'm realizing I have a major bug in a service that I'm providing to my customers. Why wouldn't I have, if I'm having a contract with my vendor, for example, why wouldn't I have a process for that vendor to streamline and patch live to my system? Obviously, I would need to approve it, and that's fine, for me to be able to have control over that process and to approve or not to approve such a patch. But I should be able to have that delivered on the spot the second the vendor provides the patch, for example. So this point is about taking the best practices from that industry and applying that for NFV as well. Monitoring, being able to understand what's happening not only for configuration, for example, but also being able to understand what's happening underneath the environment, ongoing, right? For example, I have high load of traffic for a specific tier of my application. I have one open vSwitch which is fully occupied, and a whole set of other vSwitches that are not occupied, right? I need to understand these kinds of metrics, and in fact change my application to be able to optimize based on such scenarios. And the key point here is that these metrics need to be integrated into the application itself, and the application needs to be aware of those. And last, containers. Obviously, we need a very good way to deliver software in containers. We've realized that containers are a really good way to package and deliver applications, and also isolate them across a kernel. Multi-tenancy. So when I'm onboarding a network service, obviously I could onboard a service per customer, or I would like to onboard a service and let many customers use that, but that service should be able to serve these multi-tenants, and my application obviously itself should be able to be aware of the multi-tenancy that it delivers to customers, but also from the infrastructure perspective, it should segregate the resources it consumes across the infrastructure. So at the infrastructure level, I wouldn't have that mishmash of bits coming back and forth between my tenants, between my customers. Multi-Vim support, OpenStack has become the de facto standard for the Vim layer, but in fact, it should be based on costs, not on technology. If I choose that I would like to have a certain portion of my service running on the VMware, for example, another portion running on AWS because, hey, they have multiple regions and they have many benefits that I would like to consume, I should be able to leverage that regardless of the specific application that I'm using. So this support for multi-vim environment is also crucial as part of this disruption for the cloud native VNFs. So we are here at the OpenStack Israel Day, and why, what's OpenStack role in this revolution of cloud native VNF. So firstly, OpenStack has become the de facto virtual infrastructure management for running VNFs. Many of the users, or in fact most of the users, are running an OpenStack. So that's that's a key fundamental role for that. But the reasons why OpenStack has been chosen is because it's highly customizable and highly configurable, right? So I'm a telco provider. I'm using vendor A and B for my networking gear, right? But I choose to another vendor to do my computation, for example. I choose to buy specific servers from a specific vendor. So the fact that OpenStack is highly configurable, in fact, allowed the service providers to consume and leverage OpenStack, but also configure it based on the specific needs that I have as a network service. And obviously there's a very rich ecosystem of these vendors. In fact, there are many services for OpenStack. I'm quite sure you're aware of good portions of them. And for each project for OpenStack, I have subset of vendors and plugins for their own. So for Cinder, I have their own set of plugins, and I have a whole set of vendors supporting Cinder and providing their plugin and leveraging the best of their software solution or hardware solution for storage, for example. And Neutron, which is a little bit more hyped or I wouldn't say critical, but also a critical part to providing network services. So obviously there's a huge ecosystem for Neutron as well of vendors and plugins. Also, OpenStack itself takes care of overlay and underlay. You are aware, in fact, by the Neutron API and the extensions of the API, you can access not only to the OpenStack networks or ports, the default sort of network as a service for Neutron, for OpenStack, but also through extensions, you can access directly to many of the elements and capabilities of the networking gear that I'm using underneath Neutron, right? It's not only the case, not usually, but in many cases I don't use OVS, rather I use a specific vendor, right? Like Nuage or Midonet or whatever. So I can access the capabilities of these specific vendors that I've chosen directly through OpenStack's APIs. So think of the power that I can leverage here if I'm accessing these extensions from my application. So the second, and I think not less important element of using OpenStack specifically for running VNFs is the rich set of services that OpenStack provides by itself, right? It's not only that I can, buy a virtual firewall, for example, from vendor or whatever provider, but also OpenStack itself has many services that I can leverage, right? I have firewall as a service, I have load balancer as a service, I have a courier, for example, for networking for containers. So, and this is just a small, or not a small, but a rather good example of services that OpenStack provides. And when I'm architecting my application, I can take use of these services and build my application around and with the APIs that each of these projects provide. Obviously, these days with the open tent, big tent policy of OpenStack, I have many more projects coming each release. So I can take use of these services when building my application on top of OpenStack. So this is also an important element running the cloud native VNFs. Now, so when I took all these applications, one element which is crucial to them is to be able to automate all of these processes and automate all of these VNFs on top of rich set of the VIMs and technologies that I have as part of my stack. So obviously OpenStack is one of them, but we've heard throughout the day and in many events that, I'm pretty sure that you guys also run, if you run OpenStack, you never run just OpenStack. You run a stack of software that OpenStack is just part of it. So it's important to be able to leverage them and to orchestrate them and to have some sort of orchestration and automation engine is capable of taking care of these services, but not only taking care of these services, but also taking care of the performance elements of each of these technologies, right? So I have the PDK, I have the FDIO, I have the Intel EPA, for example, for hardware acceleration. So when I'm orchestrating these VNFs, I want them to be taking leverage of these systems. I want these mechanisms to be able to first of all to be aware of these services, and the orchestration engine here is a key and fundamental part of that, since again this is the part that combines the actual software by that vendor to the infrastructure that runs that software. So another very interesting thing and that we are seeing in some of our customers' cases is where they have the embeddable orchestration need and requirement. So think of a software vendor providing a VNF to their customers. Obviously that application is being orchestrated on the service provider's infrastructure, but also internally, as part of the application, you have multiple microservices, right? Again, I'm a solution provider, I'm a vendor, and I have an application that consists out of 3 services, right? A database, for example, an application tier that does, the routing, for example, and each of these tiers need to scale. So think of the needs of such a VNF vendor, also needing to be able to orchestrate or to be able to embed a small-scale orchestrator and embeddable orchestrator as part of their application, and then providing that piece of software to the software vendor, being able to orchestrate the overall service, right? So what does it mean to be able to create that embeddable orchestrator? Obviously, for such VNF vendors, white labeling and embedding them, OEMing them as part of the solution is key element. Lightweight. If I'm a VNF vendor, I do not want to sort of waste resources on things that are not part of the core applications. The core application that I'm doing, open source and open governance, are also very key drivers, very drivers for such a solution. And portable across OSs and clouds. So the needs and the requirements for this embeddable orchestrator are quite similar to the service provider orchestrator, but it needs to be a little more lightweight. It's small, and we have obviously two solutions for that. So ARIA is a lightweight orchestration engine for VNF vendors. In fact, the ARIA's mission statement is to create that the Tosca framework that is vendor neutral and agnostic. That's and in fact anyone can just take and embed as part of the software. Where we're seeing users are using Cloudify to be that overall orchestrator, orchestrating the embedded applications. So another thing that we are seeing in the standardization bodies that has close relationship to the many open source projects that are happening right now and starting to build on top of the standard. Sometimes they are compliant, many cases they are not compliant. So we had OpenO starting, I believe, last year and turning right now into ONAP. Obviously, fulfilling Etsy's NAV architecture dream per se, but not necessarily following the exact IFA standardization that are defined by Etsy, for example. So we're also seeing interesting dynamics there between the standardization bodies and the open source implementations that are, following real world scenarios. So I'm going to skip some parts as I need to end here. But I would like to end up with a little, sort of what do I get out from this session. So we provide on-demand labs for NFV. In fact, what you get is on-demand lab with OpenStack plus an orchestrator that I can use to play around with to first of all, to get your head around building and orchestrating some sort of an application, and you get an sort of sandbox environment of OpenStack that you can get, again, on demand. So it's like a really cool sandbox environment that you can, get started with the notions that I've just described. Thank you, and if you have questions, I'll be happy to take them.